Hi everyone, good evening. Welcome to you all in another session of AIMS. In the last session, we have discussed in details the concept, the mathematical way related to regression and like regression basically, the linear one and the along with that the multiple linear one as well. Okay, so now technically we are just like we have understood what exactly is the background of it, what are the mathematical concept of it. So let's just deep dive into the coding part and take it accordingly, like how we have taken it through. Okay, so let me just share my screen. Yeah. So hopefully my screen is visible to you people. So first, of course, we need to import all of the necessary like libraries that we are having, and accordingly we need to go it like one by one. We need to just move it. Okay. So basically, if you just need to take it, so the very first thing that we have discussed, like we have taken it down with the libraries. So the very first thing we have taken the NumPy, the pandas, the matplotlib we have taken, the cbond we have taken. Okay, so we have taken sklearn.model, select, import, training and testing fleet. Then we have taken sklearn pre-processing with standard scalar. Then we have taken sklearn.linear underscore model, import linear regression because here we are going ahead with the linear regression part only, right? So we need to understand each part of it. That's why we have just taken it accordingly. Okay. And then we have taken the sklearn.matrix with mean absolute error, mean squared error, and R square. Okay, so why basically we have taken it and what way we have taken it, that's why it is giving us a better insight accordingly. So we just need to get a proper update and we just need to take it accordingly so that things are easily understandable and we can just take it accordingly. Okay, because here for the evaluation purpose, we have just considered up mean absolute error, mean squared error, and R squared error. Okay, before just starting it over, let's discuss about the evaluation part first. Then we can just move it accurately because we know about the different perspectives, like how we have to take it accordingly. Because in the last session we have already discussed about the error part. Okay, now we just need to just have a proper discussion about the evaluation part because evaluation part is very important. So we need to understand about what is mean absolute error, what is mean squared error, what is R squared error. Okay, so for that let me just take a file so that we can first discuss this and then we can just dive it with the coding section. Okay, so first is the MAE. We will be discussing about MAE. That is the evaluation part. Okay, so evaluation. Hopefully it is visible to you. So let me just zoom it. Yeah. Evaluation. The very first thing that we will be discussing, that is MAE. Okay. So MAE is mean absolute error. Okay, let's just write it. Just a moment, guys. Yeah. So mean absolute error. Okay, so this is the part about MAE, that is the mean absolute error. So first, we what the problem we are solving that we need to understand. So we are just telling the house price, and based on that, we are guessing, like we are giving in an input as the house size, and in result we are getting the house price as the prediction. This is the last example we have discussed in case of linear regression, right? So we will be first considering that only and eventually we'll move ahead. Okay. So now here it will be like, what does this MAE mean in simple words, right? So what does this mean? Mean is the average. Absolute is the like remove plus and minus sign. Absolute is like to remove the like the positive and the negative sign, and error is the mistake. So MAE actually means the average of the mistake, ignoring the plus and minus sign that we are getting. Okay, like is it like greater than the error? Like is it greater than the actual value or lower than the actual value? That we are not taking, but we are just taking what is the mean, that is the average value of the mistake or the error basically. Okay, what is error is of course the mistake, so that is average of the mistake, ignoring the plus and the minus sign that we are considering. So why we are removing this plus and minus sign? So because some guesses are too high and some guesses are too low, right? So if you don't remove the sign, ultimately like the positive plus 5 and plus 5 becomes plus 5 and minus 5 becomes 0, right? So we just need to take the just the absolute value, not the value, the positive or the negative value. So if the value one is plus 5, another is minus 5, we are getting at the end 0. So that we don't want to take. So we are just taking the absolute value accordingly. So that will actually take the values we want to take. Okay. Now let's just take an idea. Like let's just take an data set to help you understand. Suppose first we are having the house. Next we have the actual price. And then we have the predicted price. Okay. So here you can understand like house is A, this house is B, this house is C, and this house is D. Okay. Now coming down to the actual price in lakhs, of course. So let's take it for 50 lakhs, next going to 70 lakhs, next going to 90 lakhs, and then 60 lakhs. Right? And about the predicted price, it is 48 we have predicted. About that, we have predicted around 75. About C, we have predicted around 85. And about this, we have suppose predicted around 63. Okay. So these are the values, like the data we have got accordingly. Okay. Yeah. So these are the data that we have got. So first step would be finding the error in each of the house that we have got. So this would be actual minus predicted. So 50 minus 48 is 2, that is plus 2. Coming down to here, okay, let's take it plus 2 within quotes so that it can state accordingly, because we just need to give you an idea what exactly is the part. Okay, fine. So now taking it down for 70 minus 75, that is minus 5. About 90 minus 85, that is coming down as plus 5. About here, that is 60 minus 63, that is minus 3. Okay, so these are the values we have got accordingly. Okay, now we have to take the absolute value, not the values with this positive or negative sign. So we will be taking 2, we will be taking 5, we will be taking 5, and again we will be taking 3. Okay, now we need to add all the absolute errors. So this all are my absolute errors. Okay, so we need to add it up. So after adding it up, we will get the value 15. Okay, so we have got the value 50. Now the next step after we have got the absolute value, like the summation of the absolute value, we need to divide by the total houses. Like the number of houses is 4, so it will be 15 by 4. So that will be actually giving us, okay, 15. Okay, it is taking accordingly, like it is doing 15 divided by 4 that we want to do. And after we are doing it, we are getting the result as 3.75. Okay, so this is the result of 15. Why we have done divided by 4? Because the number of house here is 4. That's why the value of n here is 4. So we are doing 15 divided by 4. So we are getting the value as 3.75. Now the final MAE answer that we are getting is 3.75. Okay. So now what does this MAE actually mean? MAE equals to 3.75 actually means. So it actually means on average our house price guess that we are making, that is going wrong by 3.75 lakhs. Okay, so we need to just have an explanation about it. So suppose the actual price is 80 and the predicted price is around 75, right? So the error is coming up, that is equal to 5, because it is 80 lakh is my actual price and 75 is my predicted price. So the actual or the error that we are getting, that is 5. Okay. So now if this MAE is accurately 4, then on an average the predictions are going by 4 lakh. Okay. If after all of this, for all of the house we have checked, then we have got, suppose the MAE that is equal to 4. So that means that on an average, the predictions are going wrong by this 4 lakh, by 4 lakh. Okay. So why MAE is a good evaluation matrix that we need to understand, because it is good to understand and easy to understand at the same time, and have the same unit of price accordingly. Like the unit, if that is not about the price, if it is actually going down to marks, in that case also it will be taking it accordingly, and it is less confusing. It is easily can be taken accordingly. So that is going down based on the MAE. Okay. So if the value of MAE equals to 0, in that case, that means there is no mistake at all. My model is running absolutely fine and we can take it accordingly. Okay. Now let's discuss about MSE. MSE is mean squared error. Okay, so what the problem we want to solve? Like it guesses the house price. Sometimes it is suppose a little wrong. Sometimes it is very wrong. That we need to understand, right? So we need to just take it accordingly. So what is MSE? That is mean squared error. Okay, mean means the, of course, the average. Squared means multiply the number by itself. That means we are getting the square of it, and error is, of course, the mistake. So we are taking the average of squared mistake. Okay. So now we have to remove, of course, for here also we need to remove the positive and the negative. If we are not taking it also, then also at the same time we will be squaring it up. The negative will be turned to positive. Okay. So that is the major case. Now here, suppose the errors, like we are just taking the errors. So if the errors are coming out as 1, 2, 5, and 10, in that case, my squared error will become 1, 4, 25, and 100, because we are squaring it up, right? So this becomes accordingly. Now, if we are taking this value, like again, this value itself, we are taking this value. Okay. Now we need to calculate the error. Of course, we have taken the error like this. So this would be my error, and this is my absolute error that we have taken. Okay. So this is my error and this is my absolute error. So now in this case, there is no point of taking the absolute error in case of squared, because after at the point, if the value is -5, we are at the end, we had to do the square of it. So -5, squaring of -5 is giving us 25. So that is quite possible. There is no issue with that. So now squaring it up, it is giving 4, it is giving 25, it is also giving 25, and it is giving us 9. So we can ignore and just changing the positive and the negative value, because at the end we are squaring it up. So the negative value will be turned to positive. Okay. Now again we need to square it up. So the squaring of 4, 25, 25, and 9, that is 50, 50, 59, 59 plus 4, that is giving us 63. 63 is my adding of all of the squared errors. Okay. Now I want to divide now we want to divide by total houses, that is the mean. Okay, so the number of houses here as well is 4. So MSE is coming down to 63 divided by 4, that is 15.75. Okay, So this is my MSc. So MSc is my final result. So here you can see for MAE, we have got the value as 3.75, but in case of MSc, we have got the value as 15.75. Okay, so this is my final result. So what does this MSE equal to 15.75 mean? So it means the average of the squared mistake is coming down around 15.75. So the unit is not, of course, in lakhs, it is in lakh square here. Okay, it is in lakh square. So basically, if I need to get a proper formula for MSE, so MSE, the proper formula is 1 by n sum actual minus predicted, actual minus predict, and the square of it. Okay, and here the sum, we have to just put the square accordingly. Yeah, yeah, like that. Okay, so MAE, now just discussing about MAE and MSE. MAE is the average mistake, but MSE is the average squared mistake. So this is the major thing. Okay, so if again this MSE is 0, so that means there is no mistake at all. My model is perfectly working. There is no problem with my model. Okay, now coming down to RMSE. RMSE. Okay. So RMSE is root mean squared error. Okay. So root mean squared error. But first we need to understand like why do we need root mean squared error? We already know about MSE, that is mean squared error. But MSE has a small problem. What is that problem? The unit that we are taking, here the value that we have taken that has came accounted to lakh square because the unit is in lakh and it has came up as lakh square. So its unit become price square, right? So that is hard to understand. Okay, that is why we are taking it down to RMSE. R is root, M is mean, S is squared, E is error. That is square root average accordingly. Right? So the thing is M is root. Root is of course meaning the square root. Here coming down to mean. Mean is of course the average. Squared is the error multiplied by itself. That is squaring up the error, and the error is of course the mistake. So it is like square root average of the squared version of the mistake. Okay. So the square root of the average of the square mistake is the thing that we want to get into. Okay. Now accordingly here also for the same data, the error we have to find out, that is the error that is actual minus predicted value. So we have already found it out. So this is the error. Okay. So this is the error. Now we need to square it up. If we are squaring it up, then we have got the value like this. We have got the value like this. Now we need to find the mean. So of course, for this, the value is coming out as 63 and we have to divide it by 4. So the value is coming up as 15.75. The same as MSE. So we need to first find the MSE and then need to take the root over it. So root of 15.75 is giving the value around like approximately around 3.96. Okay, so this is my result of RMSE. Okay, so MSE is the squared version. So basically MSE is the squared version and root mean squared is the value we are getting in MSE. The root square rooting that gives us the value of RMSE. Okay, so this is the final result. So this is actually on an average, our house price guesses are getting wrong by around 4 lakh, we can say, like summing it up. So some unit, like here also the unit or the sum unit are coming down in a single unit. It is not getting squared up. Okay. So if we have to just take about why RMSE is better than MSE, we need to take into account about the unit squared. MSE is unit is getting squared. RMSE the unit is staying original. It is not getting squared. So it is taking the original part of it. So this is all about RMSE. Now, if I need to just compare about RMSE, MSE, and MAE, so that is MAE is the average mistake that we are taking. There we are considering the absolute error. MSE, we are taking the average of the squared mistake, and there we are not taking the absolute because we are squaring it up. At the end, we are getting the positive values only. Coming down to MSE, that is the size of the mistake in real unit. So the units are not getting squared. So that is the best part. Okay. So this is all about the details that we have discussed. Now we will be discussing about R2 score. Okay. So what is this R2 score? So first we want to understand what is this R2. So R2 score actually tells us actually how well our model understand the data. Okay. So R2 tells how much of the story of the model has been learned accordingly. Okay. Suppose the teacher explains according to the makes the student understand the syllabus of 100 marks, but the student understand according to the 85% of that only. Okay, so the student is telling that I understand 85% of this chapter. Okay, so that exactly what R2 score does. So if the value of R2 square R square value is 1, if the value of R squared R2 score is 1, that then the model is perfect. The model is perfect. Coming down, if the value is suppose zero point 0.9, then it is very good. Okay, not 0, 0.9. Then it is suppose very good. If it is around 5, 0.5, it is average. And if it's suppose 0, then it hasn't learned anything. Poor. And if that is giving us a negative value, that means that, okay, let's see, it's negative. If it is giving us a negative value, that means it is unable to predict it accurately. Unable to predict it accurately. So this is not able to predict correctly. Okay. So this is the details that we have discussed accordingly. So this is the part that we need to take it accordingly. Right? Like this is the evaluation part that we need to take it. Right? So now coming down to the problem, of course, we have imported the libraries. Now we had to create the data set. So for creating the data set, we have just taken it accordingly, like what is the point, what is the purpose that we have discussed accordingly. Okay, so we have discussed this accordingly. What is the point? Like we have taken the data and we have taken many fields accordingly. We have taken the area square, we have taken the bedrooms, number of bedrooms, we have taken the house age, what is the age of the house, what is the distance from the city, what is the price. Accordingly, we are given this data set. Like we have created this data set and just converted because this is a kind of dictionary format that we have taken the data in dictionary format, then we have converted into data frame because our model needs to take we need to convert the data into a data frame format, like the dictionary format to data frame format, so that my model is able to understand each and everything in detail. Okay, so after we have converted it down to the data frame format, we have just seen the we have just seen the head. Okay, we have just seen the head, like we just wanted to see how my data set is coming up. Okay, so this is the way my data set look. It is coming out. Now I have just checked for the missing value. For each of the rows, are we getting any of the, each of the columns, are we getting the missing value or not? So we have concluded that there is no missing value accordingly. Next, we have checked for the duplicate values. So we have not got any duplicate values. Now we have just checked for the description. So it has given me the description of the data set. What is the count? What is the mean? What is the standard deviation? What is the mean? What is the Q1, like quartile one, that is 25% of the data, 50% of the data, 75% data, and the max data. So for all of the columns of the data set, I have got all of these values because all of my data set, in the data set, all of the columns that I am having or the features I have considered, all are numerical. There is no categorical column accordingly. So we can take it accordingly. There is no issues with that because at the end we would be only considering, we have only the numerical values. So for all of the columns, we have got all of these values accordingly. Now we have got according the EDA, that is exploratory data analysis. So first we have just gone ahead and distributed the house range. So we have got the frequency and the price. So accordingly, it has given me the range. So like we wanted to take it based on like the histogram plot, we need to take it based on the house price. So you can see this is the price wise we are getting it. This is the way. Next, we have taken a distribution of numerical features. So all of the numerical features that we have got, we just wanted to show how the distributions are coming. So we have got the average square feet. So we have taken the distribution accordingly. Next, we have the bedrooms. So for bedrooms, we have taken it accordingly. The age of the house, this is the distribution how I am getting. The distance from the city, this is the distribution I am getting. And also for the price, this is the distribution I am getting. Now I need to detect the outlier. For that, I am plotting the box plot. So here we can see about the area, square feet, like no major outliers we are getting up here. So these are the values for price. This is a bit higher. That's why we are getting the values in this form. But for in case of square feet, area, square feet, bedrooms, house age, and the distance from the city, the values are quite less compared to the price. That's why the values are like this. Okay. Now coming down to age versus price, area versus price, sorry, the area of the house with the price. So we have plotted a square, the scattered plot. You can just see how it is plotted. So this is the plot that we have got accordingly. Now coming down with bedrooms versus price, because for all of the parameters or the features that we just need to have a proper discussion and understanding about all of the features that we have, right? So with all of these features, we can't just neglect each part of it. So we have to take it accordingly. Okay. So we have taken it accordingly. So we have got the square box plot and this we have taken the bedrooms, the number of bedrooms with the price. So this is the box plot we have got. According to house age and price, so this is the scattered plot. So it is well scattered accordingly. You can see. Coming down to bedroom versus price, so this is the plot we have got. House age versus price. So this is the plot we have got. Now distance from the city with the price. So this is the plot we have got and the paired plot all together we have done it so that we can get the understanding about it. So this is the pair plot we have done for all of it. Price with area square feet, like what is the area of the room, next is the bedroom, next is the house age, the distance from the city, the price, next coming down the distance from the city with all of this, like distance from the city with the area, distance from the city with the bedroom, distance from the city with the house age. Next, we are getting distance from the city with the price, like this we are getting. Now we have this heat map. So you can see that this red area actually gives us the more correlation, shows the most correlation over it. And accurately, we can understand about the part accurately, like about how they are actually correlated. And this is the violin plot for price distribution by bedroom so that we can get a better understanding. And this is the actual insight. So this is the regression line that is giving based on the area versus price. So this is basically my regression line. So this is actually giving us the line that we actually needed. Okay. Now we have done the feature engineering because we have used price per square feet that we have included up here. So we have done the price. Price is already there in my data set. So I have taken price divided by square feet. So here I am getting the price per square feet. Okay. So this I have taken as the as a feature engineering. I have added this. Next, I have done the feature selection. So we have taken the price. So we have just taken it accordingly and we have got the feature selection because price is the key area that needs to be taken. Next, I have splitted my data set accordingly. So I have just taken X train, X test, Y train, and Y test. So we have splitted it accordingly into 80 to 20%. So for the test purpose, we have kept the 80% of the data has been kept for the testing purpose, and the rest, sorry, the 20%, sorry, really sorry, the 20% of the data has been kept for the testing purpose, and the rest 80% has been given for the training purpose. Now we are done the feature scaling because we need to take all of the data in the similar range. As you understood from the plot that the price range were going high because they are in lakhs, but about the rooms, about the age of the house, they are in like 1, 2, or about this age I am saying, on about the rooms also, they are not that much, right? So we need to just take it, scale the columns accordingly so that we need to take it accordingly. Okay. So now we have to go for the model training. We have trained the model accordingly. So once we have trained the model, we have used the linear regression. So we have done the linear regression. Then we have just gone for the prediction and then the model evaluation. So here use the model evaluation. You have got the value of MAE, MSE, MSE, RMSE, and R2 square. So these are the values that we have got for MAE, MSE, and RMSE. Okay. So here this value is not perfectly like not perfectly zero. MAE value is not zero, so that we can't say this my model is perfectly working, right? So that's why we just play accurately prepared the like the actual and the predicted visualization so that we can just get it accordingly, and we have just taken the model coefficient. So what are the model coefficient? Because my formula equals to y equals to m1 x1 m2 x2 m3 x3 plus b, like that, because m's are the slope, so we want to get the coefficients accordingly. So these are the values of the coefficient that we have got. Now we want to predict on the test data. So here we have got the actual price and the predicted price with the test result. So here, like if you can see here, here is my actual price with the predicted price. So the actual price are not going that well. You can see it is 1.022 like that. It is coming, but the actual price is this. So we have just checked for the values accordingly. So let's just run it first. Okay, it won't be running because we need to run it from the beginning because we haven't taken the data set. So let's just run it from here. Just a moment. Okay, we are running each of the cells so that it is becoming easier for understanding. Okay, let's just keep this part because that is of basically of the visualization that we have already discussed, and we'll just move it to here basically. Yes. Yeah. Now, if I am saying it like that, so you can see the values are coming like this: 2436796.14, like this, the values are coming. So we'll just take it and running it, and we have got this value so that we can just take it a comparison. So the values are, the actual value is 13495,300, and the predicted value is 102226 right? So we have 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8. So the my value is predicted value is lower than the actual value, right? So that we can see here. Now we need to calculate the evaluation matrix. So this is my evaluation matrix that we are getting. R2 value is coming up as 0.30. That means my model is unable to understand it accurately. If my R2 value is 1, that means it is taking it accordingly, like it is understanding, my model is able to understand it accordingly. This can happen because of the lesser number of, we have taken many fields, like we have taken the independent, many independent variables, like the house price. The house price is the main one. The square, like the area, the distance from the city, the number of rooms we are getting, the age of the house. All of this field we are taking, but the data set is quite less, right? That's why my model is unable to learn accurately. Now I have just taken the actual versus predicted scattered plot. So this you can see here accurately how is the plot coming from here. Then we have this residual analysis. So we have the residual distribution we want to see, like how my residual distribution is coming out over the counts. Okay. Now, if this is my residual versus predicted value, this is my predicted value, how I am getting, and the error percentage. Okay, I need to just run it through. Just let me run it. Okay, before that, I haven't run the previous one. So we need to run it. So we have run this one. Okay, this is the value. Here I am running it because this calculation part we are getting so that we can just compare it accordingly. So now you can see the whole value. So this is my actual price, this is my predicted price, this is much error I am getting. So around 25% error in we are getting accordingly. Okay. So this is the error that we are getting. So now I just wanted to check if my model is overfitted or not. So for the training R2, my R2 value is zero point 0.6, but in case of test, my value is going for zero point 0.3, right? So here we can understand that for the training purpose, the R2 value, my model is understanding the data around more than around 60%. My model is understanding the data in the training set. But in case of testing, it is unable to understand it accurately, and we are giving the prediction like this. That's why we are getting the error percentage like this. Okay. So this is all about the error accurately that we have taken. So again, we will be taking another data set and we'll try to include, like, make the model run with this linear regression problem, and we'll just showcase and understand how the data is coming out. Is next time my model is able to understand it quite well, or what exactly is the scenario that we will be understanding. Okay. So for today, we will be wrapping up our session here. So hopefully you have understood, because what are the, like, if my model is learning good, that is well and good, the prediction is fine. If my model is not running good, so you can see the model is not predicting that well. There is a error that is coming. So we need to redo it again with a more data so that we can take it accordingly. So we'll just see in the next session how we can do that. Okay. So thank you everyone for connecting in today's session. We will be just wrapping up our session today here. We'll connect in the next session and we'll continue from here. We'll see it how we can just figure this thing out, because major issue for this error is the lack of the data that we have given in the training. So we need to increase the data accuracy, and also, if possible, if we can just decrease any of the field, that would be good. If not, if we want to stick to the all of the fields, then we need to increase the number of data sets. If we are increasing that, that will solve the major problem. Okay. So we'll see that how we can do that, and eventually we'll take it from here. In the next session, of course, we'll code out and just go for the classification kind of problems. Okay. So we'll understand what is classification and eventually we'll move. Okay. So thank you everyone for connecting in today's session. We'll connect accordingly in the next session. Thank you everyone. Bye.